All right, it's Mr. P helps with Precal Unit 5. Unit 5, Topic 1, Lesson 2. We're going to be multiplying matrices of different dimensions. Start off with a review of our scalar multiplication. So what are we trying to find? We're trying to find x. X is right here. 3 times what is negative 18? That would be negative 6, so the answer is C. All right, multiplying matrices means you're multiplying things with different dimensions, different rows, different columns. We'll talk about when you can multiply them and how you're going to multiply them. So first, a quick review of what are the dimensions of this matrix. This is a 3 by 4, and you know that because there's 3 rows. It's always rows first, columns second. What is the location of negative 4 in this matrix? So this is matrix A, and negative 4 is right here. So this is row 2, column 3, A2, 3, like that in subscript. So that would be row 2, third column. That's choice A. What are the dimensions of this matrix below? So this is a 3 by 1, and I know that because it has 3 rows, 1 column. 3 rows, 1 column. What are the dimensions of this matrix? So this is a 1 by 2. 1 row, 2 columns. All right, quick and easy. So now let's get to the meat of this lesson, which is how do we find a product of AB? So how do I multiply a matrix times another matrix? Not a number times a matrix, which we did in scalar multiplication. This is a 2 by 2, and this is also a 2 by 2. When you look at these being multiplied by each other, you have to look at the inner dimensions. These two numbers are exactly the same, which must occur when you're multiplying two matrices. If these two numbers in the middle are not the same, then these two matrices cannot be multiplied by each other. Now, the result will always be the two outside numbers. So the outsides happens to be a 2 by 2. So when you multiply A times B, you're going to get a 2 by 2 as your answer. The inner dimensions must match to multiply matrices. Okay, so A1, 1. So if I'm going to find this spot, so I'm trying to find this new matrices. So what I do is I multiply, this happens to be this, so I'm going to multiply the first row by the first column in order to get the first row, first column. This point right here is in the first row, first column. So I'm going to multiply the first row times the first column. So multiply the two numbers that happens to be in the same spot, so negative 1 times 0, and you're going to add that to the second number of this row, which is 7, times the second number in this column, which is 2. Now, negative 1 times 0 is 0, and then 7 times 2 is 14. So this number is 14. All right, so now what about if I want to do first row, second column? So first row, second column would be this number right here. So I'm going to multiply this first row by this second column. So negative 1 times 4 is the first number in the first row and the first number in the second column. And then you're going to add it to the second number of the first row times the second number in the second column. All right, so that makes negative 4 plus 7, which ends up being 3. Now, if I want to find this number, which is A21, which happens to represent the second row, so I'm going to multiply the second row times the first column. Second row times first column. So that's 6 times 0 plus 3 times 2. All right, 6 times 0 is 0, and then 3 times 2 is 6. Add those together, and you get 6. And then the last one, which is 2, 2. So I'm writing second row times second column. 6 times 4 plus 3 times 1. 6 times 4 is 24. 3 times 1 is 3. Add those together, you get 27. And voila, that is your answer. Okay, what about B times A? So I'm going to go through the exact same process, and I'm going to do, this is going to be the answer right here. So to find the first row, first column, I'm going to multiply the first row, the first. Okay, this is B times A, sorry. First row of the first times first column of the second. So I'm multiplying this by this. So it's backwards now. So that's 0 times negative 1 plus 4 times 6. All right, 0 times negative 1 is 0, plus 24 is 24. Now I want to find first row of the first one, times second column of the second one. All right, so that would be 4 times 7, which is 28. Add that to, oh wait, I did that wrong, didn't I? 0 times 7, sorry, 0 times 7, and then 4 times 3. So that's 0 plus 12 makes 12. Okay, so for down here, that would be second row, first column. Second row, first column. Okay, so second row, first column. So that's 2 times negative 1, and then 1 times 6. All right, so that's negative 2 plus 6. Negative 2 plus 6 is 4. All right, and then the next one is going to be, so this is second row, second column. So second row, that's this row, times this column. 2 times 7, which is 14. Add that to 1 times 3. 14 plus 3 makes 17, and there's your answer. Now, do keep in mind that this can all be done in your graphing calculator as I pull mine out at this point. This is actually very, very easy done in the graphing calculator. So if you go to go to matrix, which is, it tells you right here, it's second x to the negative 1. So matrix is right here. You'll see the word matrix right there on top. So if you go second and press this, second matrix, it gives you this screen. And then you're going to go right twice to edit. And when you do that, it looks like this. And then you can press enter. And it's going to ask you to write the dimensions of the first matrix. And you just put that in. And then you edit it. So you put in the numbers for that matrix. You do the same thing for another matrix. And then you can just literally go back to your blank screen. So clear that out. So second quit. Go to this just blank screen, and then you can type A plus B. So we can go to matrix and then press enter on A. So when you're on this screen, just press enter, and then it'll do this, and then you can write times and then do the other matrix, and then it will calculate it for you, and it will show you the answer to the question. Or it will say error if those two matrices cannot be multiplied. So remember, this is a 2 by 1. This is a 1 row by 2 columns. Can these two be multiplied? Yes, they can. What will the product be? It'll be a 2 by 2 matrix will be the answer. Is AB defined? Yes. If so, find the product. Okay, so we know it's going to be a 2 by 2. So I know it's going to have an answer here, an answer here, an answer here, an answer here. It's going to have 4 elements in the end. Okay, so if I'm doing A times B, so that would be first row, this would be first row, first column. So first row times first column. 6 times negative 5 is negative 30. This point right here is first row, second column. So that's this row times second column. 6 times 4 is 24. This point right here would be second row, first column. Second row, first column. So I multiply second row times first column. Negative 3 times negative 5 is 15, and then second row, second column. Negative 3 times 4 is negative 12. All right, is BA defined? If so, write the product. Okay, so this is a 2 by 1, and this is a 1 by 2. Can you multiply these? Yes, you can, because these two are exactly the same. 2 by 1 and 1 by 2. Isn't this the same thing we just did? Oh, I'm doing B times A. Oh, I'm sorry. B times A would be this times this. So erase this. That would be times 2 by 1. So will this be able to be multiplied? Yes, it will be. And it will be a 1 by 1 matrix. So it's literally just going to be one number. So if I want to do that one number, so I'm going to multiply the first row times the first column. First row times first column. All right, so that's negative 5 times 6 plus 4 times negative 3. Negative 5 times 6 is negative 30. 4 times negative 3 is negative 12. Add them together and you get negative 42. There's your answer. So the order does matter for multiplication, which sounds a little bit silly because usually multiplication has commutative property, but not when you're dealing with matrices. They do not. Order does matter. Is AB defined? If so, write the product. So this is a 2 by 2. It's A times B. I'll make sure I have the right order. This is a 2 row by 3 column. Yes, it does. So these two are exactly the same, which means yes, that's a check. And the answer is going to be a 2 by 3. So the answer is going to have 2 elements here, 2 elements here, 2 elements here. Now, how do I find those elements? This happens to be first row, first column. So first row of A, first column of B in that order. So that's 2 times -1 is -2. 2 times -1 plus 3 times 0. All right, so that's -2. This is first row, second column right here. So 2 times -6 plus 3 times 5. So that's -12 plus 15. -12 plus 15 is 3. All right, so this point right here is this element is row 1, column 3. Row 1 times column 3. 2 times 3 is 6, plus 3 times 2 is also 6, makes 12. Okay, so now how to do these points down here? Exactly the same. So this would be second row times first column. So 7 times -1 plus -4 times 0. So that's going to be -77. This point right here is row 2. That's this row times this column. 7 times -6 plus -4 times 5. -42 plus -20 more makes -62. Last one, 7 times 3 plus -4 times 2. 21 plus -8, what is that, 13? And due to my time restraint, I think I've pretty much covered everything right now. I'm going to just go over one more question right here. B times A. So let's do commutative property. Let's make sure this works. This is a 2 by 2. This is a 2 by 3. Now remember, 2 by 2 is over here, so you are actually doing B times A. Do these two match? No, they do not. So therefore, B times A is not defined. There is no solution to this answer, to this question. One more, because I know I am running out of time. This is a 1 by 2 times a 2 by 2. This can work, and it's going to be a 1 by 2 answer, which means the answer is going to look something like this. Now, how do I find element 1, 1? So that's row 1 times column 1. So that's 2 times -5y plus -5x times 0. Well, anything times 0 is 0. And 2 times -5y is -10y. All right, I'm going to do the exact same thing for the other one. So that would be row 1 times column 2. So that's 2 times -x plus -5x times 6. So that's -2x plus -30x, which makes -32x. Okay, find the value of x and y in the matrix below. So I did forget about these, and I do have a 15-minute time limit. I have a minute left, give or take. So if I'm going to be multiplying these, I want to try to figure out what's x and what's y. So I can use any of these elements that I want. So let's say I'm trying to find x. Then all I have to do is use one of these elements that uses x. So how do I find 33? To find 33, it happens to be in row 2, column 1. So I use row 2 times column 1. So that's x times -1 plus 6 times 5 equals 33. So that's -x plus 30 equals 33. Subtract 30 from both sides, and you've got -x equals 3, which means x equals -3. There's your answer. I can do the exact same thing for y. Here's y. I can use this element right here, this answer, to find y. So that would be row 1 times column 2. So 3 times y plus -1 times 4 equals 14. So that's 3y plus -4 equals 14. Add 4 to both sides. 3y equals 18, which means y must be 6. And I have 20 seconds left, so I'm going to have to stop right there. Please give it a like if I helped you learn how to multiply two matrices by each other, and have a wonderful day. Thanks again for watching.